Namaste. Welcome to Pabson Distance Learning Education collaborations with JanataTelevision. This today grade 9 science, and in grade 9 science today we will discuss about the equation of motion. So we will derive the different formula related to the equations of motion in the linear form. So today we will derive this one. So before deriving this equations of motion, some terms we need to know. So what are those terms? Let's see. So let's remember this word SUVAT, SUVAT, right? With the help of this, we can remember the component required for this equation of motion. So S, it stands for the distance. S stands for the distance. U, it's a initial velocity. Initial velocity. V, it's a final velocity. Final velocity. A, it's a acceleration due to gravity. Sorry, this is acceleration only. It's an acceleration. And T, it's a time taken. Time taken. So this one is the 5 component that we need to know on these equations of motion. So let's derive the formulas that related to the equations of motion. So firstly, I will derive the first equation. So for that we have from formula of acceleration, from definition of acceleration. So acceleration equals to, this is change in velocity divided by time taken. So from the definitions of acceleration, it's a change in velocity by time taken. So if there is 2 velocities there, initial velocity and the final velocity is there, then change in velocity will be final velocity. Final velocity will represent this final velocity by v minus initial velocity, which is represented by u divided by time taken t. That means we can represent like this: A equals to V minus U by T. So this one is the formula for the acceleration. Now from this definition, so let's simplify this, or AT equals to V minus U, or V equals to U plus AT. So this is the first equations of motion. Clear? So this one is the first equation of motion. So let me write down this here. First equation, V equals to U plus AT. So first equation. So let's move on to the second equation. So how to derive the second equation? So for deriving the second equation, we know the formula of average velocity. So average velocity equals to distance covered by time taken. So we can simplify this: distance covered equals to average velocity into time, right? And if there is 2 velocities are there, then the average velocity is U plus V by 2 into T. So this one distance cover will write down by S. So S equals to U plus V by 2 into T. Now we are going to derive the second equation. So in second equation, this V is absent. What I mean is, so from this first equation, we will replace the value of V in here. That is, or S equals to U as it is, plus, instead of V, we can write down this U plus AT. That is, U plus AT divided by 2 into time. So let's simplify this. Or S equals to U plus U is twice u plus at. So this multiply by t divide by 2. So further simplification, s equals to, so this one multiplication is 2ut plus at square divide by 2. So let's simplify this one. So when we separate this, then we will get that second equation, that is s equals to, so here 2ut by 2 plus, so this one is 1 by 2. Okay, let me write down this on left. So once again here, so this one, s equals to, this is twice of ut divided by 2. Let's separate this, 1 by 2 into at square. So this and this cancel, therefore s equals to ut plus half at square. So this one is second equations of motion. So let me write down in the right hand side here. Second equation is s equals to ut plus half at square. So this is the second equation. Now let's move on to the third equation. So for the third equation also, so we'll start from here. And in third equation, the time is not present over there. That's why instead of time, we will replace the value and we will simplify. That is, so from here, this time, or s equals to u plus v by 2, and instead of time, we'll replace the value. Like a equals to v minus u by t is there. That means t equals to v minus u by a. This value we will replace. That is, instead of time, we can write down v minus u by a. So let's simplify this, or s equals to, so this u plus v is there, we can interchange because positive sign is there. That is v plus u and v minus u divided by 2 into a, or 2sa. So this one cross multiplication one equals to v square minus u square. If you further simplify this, then we can write down this v square equals to u square plus 2a as this one is the third equations of the motion. So let me write down in the right hand side. This is v square equals to u square plus 2as is the third equation. And one more equation is a equals to v minus u by t. And next one more is s equals to u plus v by 2 into t. So sometimes you can use this formula also, and but generally this three formula we will use to solve the mathematical problem. So this is the equations of motion, derivations of equations of motion. Now there is some numerical problems are there related to this one. And before starting this numerical problem, some points that we need to remember. Let's see. Okay, before solving this numerical problem, so we need to remember some point, that is, if the vehicle or if the object start from the rest. Suppose this object is there, it is initially in the rest, mean its initial velocity is 0 meter per second. Remember that, okay? If the vehicle or if any object start from the rest, then initial velocity is 0 meter per second, okay? And if the brake is applied, that means whenever we apply the brake in the vehicle, then the vehicle comes in the rest at final. That means the final velocity is 0 meter per second, okay? If the vehicle start from the rest, initial velocity is 0. If the vehicle comes in the rest after applying the brake, then the final velocity is 0. And one more thing, out of this 5 formula, we will use one formula for finding the unknown quantity or unknown parameter, whatever unknown parameter is there in the question. For finding that, we need to use the one out of this 5. And how to choose these formulas are, for example, if there is distance, we no need to calculate the distance. Suppose the 4 component only there. Out of this SUVAT. Let's say S is there, U is there, V is there, and A is there. This time is not there. Then we choose the formula which do not contain time. So here, if the time is not there, then here is time is present, time is present, time is present is there, time is there, but in this equation, the time is not there. That's why this is the suitable for that numerical problem, right? Similarly, let's say S is there, U is there, V is not there, A is there, and T is there. That means if V, final velocity, is not there, then let's check which formula is suitable one. So V is here, so it is not suitable. V is here, it is not suitable. And here is no V. That's why this formula is suitable for that numerical problem, right? So in this way, we can choose the correct formula for the numerical problem, for solving the numerical problem. And I have already said, if the vehicle starts from the rest, initial velocity is 0. If the vehicle comes in the rest after applying the brake, then final velocity is 0. So remembering these things, let's solve some numerical problem related with these equations of motion. And for solving this also, we need to check either all the units are in SI system or not. If that is not in SI system of unit, we need to convert that into the SI system of unit. So here is one numerical problem. You can see in the screen also. A car start from the rest. We have already discussed. If the car start from the rest, then initial velocity is 0 meter per second, right? And if the accelerations of the car is 0.5 meter per second square, what will be the velocity at the end of 2 minutes, and what is the distance will it cover during that time? So let's solve this numerical problem. So firstly, we list out the given in the question. So here. So there is given a car start from the rest. That means initial velocity is initial velocity. The symbol is U equals to 0 meter per second. Okay, and the acceleration is given over there. So let's write down this acceleration. Symbol is A, is given 0.5 meter per second square. And this is also in SI system of unit is there. Then time interval is given over there. So time T equals to 2 minutes is there. But it is not in SI system of unit. So let's change this into the SI system of unit. That is 2 into 60, it is second. This is 120 second. Right? And we need to calculate the final velocity. So let's write down final velocity. So symbol is V equals to what? And similarly, we need to find the distance covered. So distance covered. So symbol is S equals to 1. So these are the given in the question. So let's see how to solve. So before this, let's check the SI unit. Either all the parameters are in SI unit or not. So this is meter per second. It is SI system of unit. Meter per second square is the second I have already changed. And the remaining is we need to calculate. Now let's choose the formula. Which formula is suitable for this one? So I have said U is there, A is there, T is there, and V is there. These 4 components are there because this distance also we need to calculate. Later we will calculate. So firstly, these 4 components are there. So having U, A, T, and V. S is missing over there. That means, so out of this, it also doesn't contain the S, and this also doesn't contain the S. So anyone you can use the formula. So I will use this one formula. So we have V equals to U plus AT. So I have already said this formula also you can use, and this formula also you can use. Anyone you can use as your wish, but I will use this one. So let's substitute the value. V is there. We need to calculate this V. We need to calculate U. It's a 0 meter per second, right? And A is given there 0.5, and T is 120. Clear? So whenever you calculate this, then you will get the answer, right? It is a final velocity. So 0.5 into 120, it gives the 60. That is 60. What is the unit? It's a velocity. That's why it's a meter per second. That's why the final velocity of the car after 2 minutes is 60 meter per second. Now, next we need to calculate is distance covered after the 2 minutes. So let's calculate this. Okay, one thing here, after finding this final velocity, any formula you can use by using this final velocity. But sometimes if the calculation goes wrong, in that condition, whatever you have found later on, that also will be incorrect one. That's why. So let's use the formula avoiding this component, final velocity. Why? Because we have calculated this. I think the concept is clear, right? So I will use the formula without having this final velocity. That means here is u, acceleration is there, time is there, and the distance is there without v. Let's check the formula. So this is the formula where v is not there. That's why this formula is suitable for this one. So again, so let me write down here again. The formula we need to use is s equals to ut plus half at square. Right? S we need to calculate. U is 0, time is 120 plus 1 by 2, a is 0.5, right? And t is 120 to the square. Okay, so this one is 0, and if you calculate this, then you will get the answer. So 0.5 into 120 square equals to divided by 2. So this is 3600. So therefore s equals to 3600 meter. Distance, its unit is meter. That's why the final velocity of the car is 60 meter per second. Conclusion you can write down at the last. And distance travel after the 2 minutes is 3600 meter. So in this way we can solve the numerical problem. So next numerical problem is there. Numerical problem number 2. So let's try to solve how to solve this numerical number 2. Okay, the question goes like this. A bus is running at the constant speed of 90 km per hour. When the driver sees a child 29 meters ahead, he applies the brake and the bus stops at the distance of 15 meters. Then calculate the time taken to stop the car and the retardations applied after the brake or applied by the brake. So let's see how to solve this one. So firstly, let's list out the given. So here is given initial velocity. So initial velocity. So symbol is u. There is given 90 kilometer per hour. So this 90 kilometer per hour, it is not in SI system of unit. It is in this system. We need to convert that into the SI system of unit. How to convert this? It is 90 multiplied by 1000 divided by 60 into 60. So if you simplify this, then this one is 2 and 30, 15, 2 and 5. This one is 5 gives the 25 meter per second. Initial velocity is this one. And it is given when the driver sees a child on 29 meter ahead. So this distance is not useful one. Remember this, okay? This distance may create the confusion to you. That's why this is not required for us, okay? Distance traveled is given over there. The bus comes in rest after the 15 meter. That's why that is a distance travel. That's why this is required one, another we don't require, okay? That means the distance covered, right? Symbol is S, is 15 meter. 15 meter. So whenever we read this question, now another component is not there. Directly it is not seen over there, but there is hidden over there. That means the vehicle comes in rest, mean final velocity will be 0 meter per second. That means the final velocity symbol is V equals to 0 meter per second. Why? Because the bus comes in the rest. Okay. Now what we need to calculate here? We need to calculate the time taken. So time taken, T equals to what? And similarly retardation we need to find. So retardation is the negative acceleration. So we will write down this minus A equals to what? So I have already converted the unit into the SI system of unit. Now let's choose the formula, which one is suitable one for this. So here is time. We need to calculate. Final velocity is there, distance is there, and the initial velocity is there. So the formula suitable one is without this acceleration. So which one formula it doesn't contain the acceleration? So this formula, which formula it doesn't contain the acceleration? This formula, it does not contain the acceleration. That's why this formula we can use for finding this time. So we have S equals to U plus V by 2 into T. So distance is here 15, initial velocity is here 25, plus final velocity is 0, divide by 2, and time we need to calculate, right? So let's simplify this. This is 15 into 2 divide by 25 equals to T. So if you simplify 5, 3, 5, 5. So therefore time T equals to 6 by 5 second. So this one is the time taken to comes in the rest. And similarly we need to find this retardation also. So how to find this retardation? Let's see. So for this retardation, okay, so I will choose the formula which do not contain the time. Okay, that means without time the formula is this one. So let's use that formula. So again V square equals to U square plus 2AS. So V square is 0 square, final velocity is 0. U square is 25 to the square plus twice A we need to calculate, and the distance is there 15, right? So one more step here. So let me write down in this place. So this one is or 0 equals to 25 to the square. Okay, 25 to the square, it gives the 625. 625 plus 15 into 2 is 30A. If you simplify this, then this 30A, we will take this in the left hand side, right? That is minus 30A equals to 625, or minus A equals to 625 divided by 30. So whenever you divide this by 30, then you will get the value. Therefore, minus A equals to 20.83. Acceleration is there, so it is a meter per second square. Okay, that's why this is being retardation, the value is negative here. It's being retardation, the value is negative. So remember that whenever we apply the brake, then the value of accelerations will be in the negative one. That is because retardation, it is a negative acceleration. Okay, therefore, so we can conclude this. The time taken to come in rest is 6 by 5 second, and retardation produced is 20.83 meter per second square. So this, by this process we can solve the numerical problem. Okay, one more numerical problem, let's see. Okay, question you can see there. A bus is moving with the velocity of 60 km per hour by seeing a baby 11 meter ahead, the driver applies the brake and the retardation produced is 13.88 meter per second square. Calculate the distance covered by the bus and the time taken to stop the bus. Okay, spelling is wrong over there. It is a to stop the bus. S is missing over there. Okay, so let's list out firstly the given. So here what is given over there? Initial velocity is given, right? Initial velocity. So initial velocity u is 60 kilometer per hour. So it is not in SI system of unit. Let's change this into the SI system of unit. That is 60 multiplied by 1000 kilometer into meter divided by 60 into 60 hour. When we multiply by 60, it changes into the minute, and when you again multiply by 60, it changes into the second. So this and this cancel. So this one is let's say this is 3 and this is 50. That is 50 by 3 meter per second. Clear? Okay, what is given next over there? By seeing a baby 11 meter ahead, it is not useful one, same as previous one. This we will not count, right? But there is given the retardation produced is given. So remember that if the retardation is given, then we need to put the value negative. That is, so we'll I'll write down here retardation. It's a minus a equals to, it's 13.88 meter per second square. So if the value of minus a is 13.88 meter per second square, then whenever we put the value of a, so I'll write down here a equals to minus 13.88 meter per second square. Remember this. Okay, if you use the positive value, the answer will be wrong. That's why remember that if there is retardation is given, then the value should be negative one. Okay, then we need to calculate. Okay, the brake is applied over there. Again, the hidden given is over there. Final velocity will be 0 meter per second, right? So final velocity. So symbol is v equals to 0 meter per second. We need to calculate the distance covered and the time taken, right? So distance covered, what is the symbol? It's a S equals to what? And similarly, time taken. Symbol is T equals to what? So we need to find the distance covered and the time taken. Okay. So how to calculate this? Let's see. All the units, they are SI system of unit I have converted, right? So for finding this distance covered, I have already said which one will be suitable. The formula is without T, because T is also unknown over there and the S also unknown over there. That's why we will choose the formula which do not contain T. So here, this formula, it doesn't contain the T. So we'll write down here. So we have v square equals to u square plus 2as. Why this is chosen is, I have already said, T is not there. Okay, so or v final velocity is 0. So this I'll write down 0 square equals to initial velocity is there 50 by 3. So I'll write down in fraction itself 50 by 3 to the square, right? Plus 2. I have said this value of a, that should be negative 1. That is minus 13.88. Okay, and remaining one is s. S we need to calculate. Clear? Or okay, 0 square is 0 equals to, this is 50 into 50 to the square is 5525, 2500 divided by 9. Okay, plus, so let's simplify this one. It will be minus, this plus and minus is minus, and this 13.88 multiplied by 2, it gives 27.76, 27.76 into s. So this having s, I will transfer this to the left hand side, that is 27.76 s equals to 2500 by 9. You can convert this into the point also, no problem, and in fraction also we can calculate as our wish, right? So for the simplification, let me do here, or s equals to this 2500 divided by 9, okay, into 27.76. So you simplify this, then that will be the answer. 2500 divided by 9, again divided by 27.76. So the answer is, therefore, s equals to 10.006. It's a distance, so unit is meter. Clear? So like this we can find the distance covered after applying the brake. And again we need to calculate the time. So formula for finding this time without the s. So without s is this formula we can use. This also we can use, or this also we can use. So again v equals to u plus at. So v is final velocity is 0, u is, that is 50 by 3 plus a is, this is negative, must be their value, minus 13.88, right? And this time taken we need to calculate. So let's simplify this, or 13.88 t equals to 50 by 3. Therefore t equals to, so let's simplify this, 50 divided by 3, again divide by 13.88. So answer it gives about 1.2. So therefore time taken is 1.2 second. So in this way we can calculate the time taken and the distance covered after applying the brake. So next, one more numerical is there. Let's solve this also. The question is like this. Okay, you can see the question in the screen also. A car start from the rest and cover a distance of 100 meter after 10 seconds. And if the acceleration is 2 meter per second square, then calculate the final velocity. So this numerical problem, you can try yourself. So we have tried already 3 questions. So in the same pattern, you can solve this. First you write down the given, right? Then after, the formula should be written down in the right hand side so that we can choose the correct one formula. Okay, and before solving, remember that either all the system of unit, they are in SI system of unit or not. After that, you can use the Laplace suitable formula and solve that, then you will get the answer. So these questions I'm leaving you as a task, so complete this and learn whatever today we have learned. Once again, you practice in your home, that makes you perfect. So for today, this much only. Thank you very much for joining. Thank you very much.